Hello everyone, welcome back to my YouTube channel. Today we are going to see Maharashtra State Board Class 10 Science 1 Chapter number 8 Metallurgy. Now in this particular chapter we are going to talk about different properties, the physical and the chemical properties of the metals and non-metals. After that we are going to study about the reactivity series of metals, ionic compounds, metallurgy, and the various concepts related with the metallurgy itself we are going to study in this particular chapter. So let's begin with some of the terms which we have already said about, like in that the first, if I'm talking about the physical property of the metals, which already we have studied in the previous standard. Like metals, they have the higher melting and a boiling point, they are mostly solid in the nature with a certain exceptional cases in that. Along with that, metals have a definite size, shape, they are ductile, they are malleable, they are strong, they are good conductor of the heat and electricity. So these kind of properties already we have studied in the previous standard. On the other hand, if I'm talking about the physical properties of the non-metals, they are almost or exactly opposite of the physical properties of the metals. They are brittle in nature, they are soft, they are found in all the three states, that is solid, liquid and gases. They are non-ductile, non-malleable, and a bad conductor of the heat and electricity. So these are the physical properties we have under the non-metals. So let's go towards the chemical properties of the metals. We have studied so many things about the metals, about their physical properties. So in this particular section, we are going to talk about the chemical properties of the metals. In that, the first what we have is a reaction of metals with oxygen. Whenever we talk about the metals, they radially react with the oxygen. In certain cases, they are very dangerous also. Like if I'm talking about the sodium metal, it's very reactive. It's a highly reactive metal we are having. If you will keep it open, immediately it will react with the oxygen present in the environment or in the air, and it will start to burn. And it's very reactive metal as compared to the other metals. So the reaction, if I want to talk about over here, you can see when the sodium is reacting with the oxygen, it's producing a sodium oxide. And that sodium oxide, when it's mixed in the water, it produces a alkali solution, that is the sodium hydroxide. Further, is the same way about the magnesium also. Magnesium is also a reactive metal. It's react with the oxygen, but here we require the heat to carry out this particular reaction. It's also producing the magnesium oxide. Means in general, if I want to talk about when the metals are reacting with the oxygen, it's producing the metal oxide. The next reaction what we have, that is a reaction of a metal with a water. When the metals are reacting with the water, in certain cases they react radially, like sodium reacting with the water, forming a sodium hydroxide, hydrogen gas, and along with that the heat is also produced. It's an exothermic reaction. Same way about the potassium. When the potassium reacting with the water, it's producing a potassium hydroxide, hydrogen gas, and the heat. So these two are the exothermic reactions. Other hand, when we talk about the calcium reacting with the water molecule, forming the calcium hydroxide and the hydrogen gas. So in general, if I want to generalize this all the reactions, then I can generalize it like metals reacting with the water molecule produces the alkali solution. It's producing a alkali solution, means the hydroxide of the metal, mean metal hydroxide will be formed along with the hydrogen gas. You can see over here in all the cases we have the hydrogen gas as a common factor and the hydroxide as the common. Some of the metals, some of the metals, when they are reacting with the water, they are producing the oxides also, aluminum oxide, ferric oxide, zinc oxide, but the hydrogen gas is a common among them. So to explain this particular section, they have taken one example over here, the glass wool and the metal sample present over here, and when we heat it, it gives a heat to it, and that metal sample react with the oxygen and forms the hydrogen gas, which is passed with the delivery tube and collected by the inverted method, because hydrogen gas is lighter than the air, so it goes upward, so it gets collected into the inverted test tube. Now the next property what we have, the chemical property of the metal, that is reaction of metals with oxygen, they have given over here, but it's not the oxygen, this is with the acid. So you can make a correction in your textbook, instead of this we have the acid. So reaction of a metal with acid. For that they have given one experimental arrangement over here. You can see here what they have done is in a test tube they have taken the zinc granules, that is a metal, and along with that the dilute hydrochloric acid also they have taken. So when this dilute hydrochloric acid start reacting with the metal, then it produces the hydrogen gas again, and in the by same method it's passed over the water or the solution, the soap solution, so it will produce a bubbles, and when we bring the enlightened or the lighted candle over near the that particular bubble, then it burns with a pop sound or the cracking noise, because hydrogen gas burns immediately when the fire comes in a contact with the hydrogen gas. So that produces a cracking or the pop sound. So this is about the reactions or the experimental arrangement. You can see here the series of metals they have given, that is magnesium greater than the aluminium, and that is greater than the zinc and the iron. This shows the reactivity sequence, how reactive they are. Magnesium is more reactive than aluminium, that is more than the zinc, and that is more than the iron. Means from this we can draw out magnesium is the most reactive among these four. Now the further is a reaction they have given over here. You can see the magnesium, aluminium, iron and zinc reacting with the hydrochloric acid, and all are forming this hydrogen gas. And the metal salt, that is magnesium chloride, aluminium chloride, ferric chloride and the zinc chloride. The next what we have to study, that is the reaction of metals with a nitric acid. Nitric acid means HNO3. So when it's reacting with the concentrated HNO3, it's producing the nitrogen dioxide or the nitrogen oxide along with the water molecule, and the nitrate of copper will be formed. The next is aquarisia. Aquarisia is a highly corrosive and fuming liquid. It is one of the few reagents which can dissolve the noble metals like gold and platinum. Aquarisia is freshly prepared by mixing concentrated hydrochloric acid and concentrated nitric acid in ratio 3:1, means hydrochloric acid raised to nitric acid, that is HNO3, and this ratio is a 3:1. And this particular solution what we have is very useful in dissolving the noble metals like a gold and platinum. Further is a reaction of a metal with a salt of other metal. Now this particular section, when we talk about the reaction of a metal with a salt of other metal, in this particular section when we talk about the highly reactive metals, they are replacing the less reactive metal. It's a simple concept. What we have, the high reactive metal replaces the less reactive metal, and for that, to understand this, we have the reactivity series of metals. You can see over here the reactivity series of metals they have given. When we talk about the potassium, sodium, lithium and calcium, this reacts with everything, almost everything. So that's why this particular section or this particular metals what we have, they comes under the category of the highly reactive metals. After that we have a set of magnesium, aluminium, zinc, iron. They are reacting with only this much. Reacts with the acid, reacts with the oxygen, and the further reacting with the noble metals. And then the copper, mercury, silver, and the last one is the gold. So gold is a least reactive metal we have, and the potassium is a most reactive metal we have. Means in any reaction, this reactivity series will be followed if the two metals are together, or the reaction between the metal with the salt solution of the other metal. Then if we have the more reactive metal, then that will replace the less reactive metal. Further is a reaction of a metal with non-metals. In this particular section, the reaction of the metal with a non-metal, and it's producing the ionic compound, and that is nothing but the salt. Simply the metal with the non-metal, when it's reacting, it's forming the ionic compound, and in most of the cases it is nothing but the salt. So this is about the chemical properties of the metals. In next video we are going to see about some more things related with the some more terms.